Now let us go ahead and set up HBase on our cluster. The instructions are same as we have seen earlier with other services. We just have to use Cloudera Manager to set up the service. However, we need to understand the architecture of the service before we use Cloudera Manager to set up the service. And then we should be able to go through the log files as well as properties files to troubleshoot any issues. Also, we should run certain commands to validate that service is configured properly on our cluster. After this, you should be able to add any service as and when it is required into your cluster by just understanding the architecture and following the instructions that are provided for that service as part of the documentation from the underlying vendor, which is Cloudera in this case. So that being said, let us go to the Cloudera Manager. HBase is kind of one of the important service which comes as part of Hadoop ecosystem itself, and hence it will be available directly as a service. So we can actually expand this and click on add service and then go to HBase. Then we can click on continue. HBase follows master slave architecture. We have to configure masters as well as slaves, and masters are typically managed by Zookeeper for high availability and fault tolerance. In this case, I'll be configuring masters on 2, 3 and 4. Typically, we choose the same servers on which Zookeeper is running. You can see here masters are on 2, 3 and 4. 6 was also selected and I have deselected 6. We should not have HBase on the slave, HBase master on slave nodes. Then I can click on OK. And then region servers are automatically picked up based on the nodes on which data nodes are running. So if a data node is running, typically it is considered as a slave node or worker node, and all those worker nodes are automatically selected for us as region servers. We can also have thrift server and rest server if you want to connect to HBase using Beeline or any other JDBC based tool. So if you want to configure those things, you can configure those also. Typically we will be configuring on gateway node. So let me choose gateway node here for HBase REST as well as thrift server, and then we can click on continue. You can review the properties here and then you can take it from there. So this is HDFS location. This is not the local file system. HBase uses HDFS as the underlying file system, and hence we have to specify what is the directory we want to use for saving files in HDFS with respect to HBase. We can also enable replication and indexing if you want. If you don't want, you can deselect them and then you can click on continue. So the meaning of HBase replication is there will be intermediate memory structure and file structure when we actually try to save data into HBase. If we want to replicate those things also, then we have to enable that HBase replication. Now HBase is added and we can click on finish here. However, it does not start the service automatically for you. You have to click on this and you have to complete the process by clicking on restart tail services. While it is restarting, let us review some of the key components with respect to HBase. We have master and we have configured master on 3 servers, 2, 3 and 4, on which Zookeeper is running. And then we have region servers and we have configured region servers on those nodes where data node is running. There are certain important components of HBase which are nothing but write ahead log, which is nothing but file structure for the data which is being read or not read but written into HBase by performing insert, update or delete. Whenever there is a write operation, those operations will be persisted to write ahead log. This is like edit logs for our HDFS. So in case HBase goes down, if we have to restore and recover, we can actually use this write ahead log to restore and recover our data in HBase database up to a point in time. And then there is a block cache. It stores frequently read data in memory. So when you actually query the data from HBase, if you are actually reading the same data again and again, those will be cached in block cache. And also on each of the region servers, there is a memcache. Memcache is the one which will actually laying in between our client operations such as insert, update, delete and the HDFS files. Whenever you perform an operation, it will get into the memory, and in some cases that will be treated as commit. As writing into memory is very fast, the operations can be faster when we use HBase as a layer while inserting into the data into the tables, even though the data is finally persisted in the files. So memcache actually hide that complexity from us, and it will actually facilitate us to perform operations into HBase tables in real time, such as create, update, delete, etc. And finally, whatever is there in memcache will be compacted into H files. Those H files will be stored into the HDFS. However, we will not access directly from HDFS.often. If we try to read the data, it will read the data from H files into block cache, and from there we will be reading the data. For that reason, the subsequent operations can be much faster. And also, whenever we try to write the data, it will use memcache. As it will not directly touch the files in HDFS, the reads and writes are much faster when it comes to HBase tables. That's why HBase can be used for real-time applications as well. That being said, by now the service should have been restarted. Actually, I forgot to click on restart here, and now it is actually restarting. Anyway, we have covered the important components of HBase as well, and we will wait until the restart is done, then we'll take it from there. Now HBase is started, we can click on finish, and let us refresh this page because it is still showing a stop. Now you can see that it is green. There are a few warnings, we can ignore them for now. Now you can click on the service and you can actually review the components. You can see that there are 3 masters and 3 region servers. You can click on the master to understand on what servers the masters are configured. Same is the case with region servers. When it comes to masters, even though we have 3, only 1 is active, the other 2 are just backup servers. You can also go to configuration and you can actually review some of the important properties. The main thing is HDFS root directory. This is the location where the files associated with the HBase tables will be saved to, and on top of this it is configured with Zookeeper, so HBase also should have information with respect to Zookeeper, and so on and so forth. There are few other properties which you should review and try to understand before we go further. That being said, now we can actually connect to the gateway node, and then we can actually run Ansible command by going to setup cluster and then Ansible. And then we can run this command by searching for Java-based processes that are running as user HBase. It is saying no such file or directory because we have deleted JDK 1.7 and switched to JDK 1.8 while transitioning from packages to parcels. For that reason, we have to search for the actual path with respect to JDK 1.8 and then bin and then JPS. So we can use this path rather than 1.7.0_67. Now I can copy paste this one and hit enter. Now you can see the H region server on Big Data Server 5, 7 and 6. With respect to 4, we got H master. In this case, we don't have all the hosts under this command. We only try to achieve from yarn. That's why we got only 4, 5, 6 and 7. However, to fix this issue, I just have to say Ansible all, and then we can run this command. It will actually get the details from all the nodes. Except for the gateway node, rest of the nodes have one or other process with respect to HBase in our cluster. You can see the region servers on 6, 5 and 7. On 4, you can see the H master along with Zookeeper. Zookeeper is not showing up here. On 2 also we have H master. On 3 also we have H master. Whereas on 1, there is no H master. However, we have started REST server and thrift server on 1. That's why we are seeing these processes here. You can also connect to the hosts. So I'm connecting to the host on which master is running. One of the hosts is nothing but Big Data Server -4. We can go to etc hbase conf and then run lsf and ltr. You can see hbase.xml and hdfs.xml files here. You can review properties from here, or you can also go to var run Cloudera SCM agent process and run lsf and ltr. You have to be root to run this command, and you can see HBase master here. You can run lsf and ltr on that directory, and you can see the runtime properties files here. You can also go to var log HBase and run lsf and ltr command, and this is the log file which you can review if there are any issues while starting the HBase server. As we have master running on this host, we have HBase master log file in this host. However, if you go to 5 and if you go to var log HBase after switching to root, and then if you run lsf and ltr command, you can see the log file here. You can open this file to review any issues related to HBase region server running on this host. So this is how you can actually get into the log files in case if there are any issues. As we have set up HBase successfully on our cluster and also as it restarted successfully, we also need to go to instances and need to ensure that gateways are configured. So from whatever nodes you want to run HBase commands or you want to deploy HBase applications, you need to configure those nodes as gateways. In our case, it is nothing but Big Data Server 1. As of now, there are no gateways with respect to HBase on our cluster, and hence we have to click on add role instances here. Now you can see the option of gateway here. Earlier that option was not there. In this case, I'm choosing every server as a gateway, even though it is enough to choose only Big Data Server 1. And then we can click on OK. And then we can click on continue. And then we can click on finish to see that the servers are added as gateway. Now we have to click on this and then deploy the client configuration so that the client configurations on all the hosts are updated to ensure that those nodes can be used as gateways for HBase. You can see that the deployment is failed, but that should be fine. It could be because of the timeout issue for whatever reason. As long as you don't see any issue here, the failure of client deployment is not that significant. You can actually click on this and ensure that the instances have the gateways. All the servers are configured as gateways, including Big Data Server 1. Now we can connect to the Big Data Server 1 and make sure we run HBase shell. If this is configured as client, then it should come up without any issues. It seems to be working fine. We can also run list command to list the tables. As of now, there are nothing. But this actually confirms that everything is set up properly. At least we are able to launch HBase shell and we are able to interact with the cluster after configuring it using Cloudera Manager. That being said, as the setup is successful, now it is time for us to validate from the developer perspective. We will see how to create tables, how to load data into those tables using HBase commands. If they are working, even the developer applications which are deployed on the cluster will work interacting with HBase cluster without any issues, as long as everything is configured properly as part of the application logic.